Hello, all. Welcome to another episode of AWS Show and Tell. I'm your host Anil Nadiminti. I'm joining from the East Coast of US. I'm in New Jersey today. I'm joined along with Lana Zhang.
Hi
Lana,
everyone. My name is Lana Zhang. I'm a senior solutions architect from AWS Bedrock specialist team focused on voice agent. I joined from Canada, Toronto, East Coast. Nice to meet you.
nice to meet you. I'm a senior solutions architect here from the enterprise solution architecture team. I support fintech customers in the Web3 space. So, and I was actually also in Canada, Toronto yesterday, Lana. So I was, doing a talk on X402. So, yeah. Today we have a great topic, right? So Lana has in the past come to the show and tell and presented on voice LLMs, and we have links to the episodes that I'll share in the chat in a little bit. But today's episode is a little bit different, right? So we are looking into the world where we have AI agents that are doing a lot of activity, right? So they are able to take up the tasks, reason, and then perform the actions, right? So now, how do you integrate voice LLMs into the agents, right? Agentic frameworks and make them enterprise ready. So we're going to dive deep into this aspect today, and how you can build and also host your AI agents, right? So voice-enabled AI agents, I would say, in AWS or on AWS, right? So, Lana, why don't you give an intro into the topic?
Sure. Um, so we can bring up the slide. Yeah, it's a simple slide. We try to cover the topic broader as a voice agent. Like a voice agent is an emerging field, just like we always say, like 2 years ago for the text agent. There's evolving frameworks, evolving models, and different communities, different styles to build your voice agent. From the AWS aspect, we like to talk about a bigger story, not only how you build it, how you choose the right model, right framework, but also how you do the agentic integration, how once you have your voice agent available, how you host it, productionize it. And also voice agent has a very specialized domain, which is contact center. For telephony integration, we can also touch upon that.
Great. Yeah, I think these are definitely some of those use cases, right? So we have agentic frameworks that we need to talk about, and how these integrate into the mainstream. Mainstream will include like different use cases. Uh, Lana is going to take us through all of these different examples here of the use cases. But more importantly, we are also going to do a demo. We're going to do a show and tell of how we can quickly build these voice agents, right? So it's not that we're going to look at a demo, but we're going to see how to build this quickly. So that's the goal for today's session.
Yeah, absolutely. It's going to be fun, right? So we'll show you some cool AS tricks, how you building a voice agent within a few minutes. Or for the agentic community, if you already build a text agent, you want to convert it to a voice agent with a voice interface, how you do it quickly as well.
And these are like a number of icons here on this agenda slide, Lana. So do you want to breeze through them as we go through this, or how do you want to do this?
Yeah, absolutely. Based on the number, right? So usually when people start to build their voice agent, step one, you will consider, okay, which framework should I use? Which model should I use, right? So the step one is, this is a builder session, right? So where how you build something from scratch by writing code. And then there's frameworks, popular frameworks from the voice agent community. One is referred as cascading, which we will elaborate a little bit. It's more like you stitch different independent models in a pipeline. You have your ASR, which is speech to text model, you have your reasoning model, LLM, and you have your text to speech model. You stitch them together. And then that's intuitive to understand, right? So the next generation is more referring as bidirectional streaming model, which is really combining all those components together and offers more advanced feature, reduce latency, improve accuracy, etc. So when you talk about the frameworks and the models, they are usually breaking down into these two architecture patterns. We can elaborate a little bit. So that is really the starting point whenever
Mhm.
people start to build their voice agent. And then you can talk to a voice model like a toy. And then for enterprise, especially agentic integration is very important. You want to integrate the tool into your voice agent so they can do a RAG lookup, so they can integrate with your API, your database. your sub-agent, etc. So that is another broader topic. On AWS, there's a collection of services you can use to build this type of agentic integration with your voice agent. Your voice agent is an orchestrator, and you have a collection of tools you can integrate. So that's a functional area. Yeah, security is another important area people will talk about. And then third area is hosting, right? So this is, we are moving to the DevOps side. So once I have a voice agent, I POC MVP, it reached my functional requirement, right? So it's able to answer my call automatically. How I host it at scale, right?
Mm-hmm.
So how I trace it, how I track the usage, etc. So that is a hosting topic. On AWS, you can host it as a traditional container managed, self-managed container service, for example, EKS, ECS. Also, you can deploy it to AgentCore runtime as a managed container, offers WebRTC and the WebSocket connection over the internet. And then last but not least is telephone integration. This is more specialized for a customer for contact center, where they have a phone number to call in. How you integrate those phone system with your voice agent as an upstream integration. And there's many popular telephony platforms. We show some logo here, like Amazon Connect, Genesis, Five9, also Twilio, OneEdge, etc. There's a long list of platforms on the market.
So we're going to show how we can integrate with the agentic frameworks and the telephony here. Is that what we're doing?
We could share some resource, but yeah, the high level is more you have a voice conversion, SIP trunking type of integration.
Yeah, I mean, exactly, right? So we are seeing voice agents everywhere in our workflow. I can also relay about the coding, right? So we are all used to coding agents and being able to code, ask questions, and give a goal to these LLMs to be able to complete a task. But they're also having, options of /voice. Now people are adding that, and then instead of speaking to the agent and asking the agent, instead of chatting with the agent, they're speaking with the agent, coding assistants, and asking to perform the tasks, right? So voice agents are also getting into the mainstream, and most importantly into the enterprise space. So this is a great topic for you to follow today.
Yeah, absolutely. So there's popular use cases, right? So we always started from this level of content. So customers from customer service, right? So they answer the call. You have a voice agent enter the hood that can help you to automate the process. Outbounding call is like you proactively call your customer. For example, their billing is due, right? So you have an automatic agent to call them, remind them to place the payment or promote some product. Voice assistant, right? So it's like a drive-through pickup. For example, you go to McDonald's and then you order the burgers. IoT device like Alexa, right? So and the other IoT device smart device you can chat with. Training education is an important use case. It's like,
Mm-hmm.
for example, contact center, they have voice agent to train their human agent for their onboarding. And shortly, I will demo you another training agent, which is technical interview. So it will ask me question and then give me feedback how good am I answering the question. And then social media, right? So this is an area really emerging. You can be super creative using voice agent to serve different use cases. Right, and then about the voice model, like we highlighted earlier, is breaking down by different camps, cascading versus bidirectional streaming. If you're familiar with voice agent, you probably see more or less these names, right?
Mm-hmm.
So cascading, which is you stitch different models together. From Amazon AWS, we have first-party service like Transcribe, which is speech to text, poly text to speech, in conjunction with Bedrock to form the pipeline. Also on the market, there's very popular providers like DeepGram, 11 Labs, Whisper, which is can be open sourced or can be managed service, right? So and then along with the corresponding frameworks like LiveKit, PepCat, LaneChain can support this type of cascading models.
Mm-hmm.
On the right side is bidirectional streaming, right? So basically, it's all-in-one. Popular providers on the market, we know our first-party Amazon Novasonic and also Gemini Flash and OpenAI Realtime fell into this bucket. And also for bidirectional streaming, there's slightly different frameworks to support the model. you will see some overlap. For example, LiveKit, PepCat, both of these frameworks supporting both architecture.
So can you break this down for the viewers, Lana, on some of these concepts? Bidirectional streaming, cascading, decouple, like maybe even more.
Yeah, let's do that. This is one of the topic we usually spend a lot of time to discuss, right? So cascading is oversimplified the logical flow, right? So basically, especially for people having familiar with text agent, right? So you know how you build a text agent using an LLM. You configure the tool so the LLM is syncing and select the tool, and then you just think about you adding the speech to text and the text to speech model on top of that to serve the voice interface. It's relatively intuitive to understand, but voice in nature is much more complex than text or multimodal image interface. Voice usually is bidirectional streaming interface. It can be WebSocket, WebRTC, and then voice, and also involving like audio encoding, decoding, VAD, like voice activity detection. You want to make sure you capture your input at a proper place, right? So you don't want to capture word by word, or you don't want to waiting for too long to capture a super long sentence which will introduce latency, right? So VAD is an important component of this type of voice agent pipeline, and also barge in, right? So for example, when we have a conversation, I interrupt you, right? So, and then you will pause and address me instead of continuously producing the response based on the previous content topic. So those are in nature complexity for voice framework. And then additionally, because between these models, it's a text interface. Therefore, there's additional latency introduced by this type of on the interface level. So we frequently referring cascading as more like the popular framework because of easy to understand and flexible to plug in different models in different stages, and the transparency, right? So because you have full control on every single steps, but in the meantime, there's drawback like complexity, latency, accuracy, etc., etc. And then we introduce bidirectional streaming model, which is really the next generation of the voice model. One of the from Amazon first party is Amazon Novasonic. So you can think about it has different components for speech to text reasoning and text to speech, but it's all in one. It's one foundation model. You can streaming in your audio and sending text to it, and also you're receiving audio back and then receiving text back. Right, so it's a much simpler interface. When you're building a voice application, it is much simpler because the model itself encapsulated a lot of complexity. And also between the component, instead of passing text, is passing additional queue with audio. So there's lower latency and also more richer context passing in between. And then there's different programming frameworks supporting bidirectional streaming interface, right? So basically, that's a simple comparison. And then we try to. This is another good slide. Too many text, but it shows the pros and cons comparing cascading and bidirectional streaming, right? So. Which is depends on what you're looking for, right? So how it works in terms of latency, in terms of barge in, voice quality, flexibility, to use, and the cost, right? So you can see pros and cons, and then make your decision wisely. All right. So that's for the frameworks and the models. Usually it's tied together, right? So specific frameworks will be.
So would you say that maybe barging in is one of the important criteria to decide, the cascading versus, bidirectional streaming options?
Yeah, barging can be supporting both, right? So, but just in cascading, it's kind of managed on the application level, and then you need it's more. You take more responsibility for this type of functionality versus bidirectional model. It managed for you, right? So you don't need to worry too much about how it's being worked, and how to find a sweet spot is managed by the model. All right, so now let's do a quick demo, right? So so we have some samples. We also want to show you how easy it is to build a voice agent using the AI tool. Just a few months ago, before the coding IDE become popular, building a voice agent is still a lot of work. Most of our champions have a very strong builder engineer background, but now we see much stronger adoption from the agentic community because of using AI to build a voice agent is much faster. So this is one. I did it in a few minutes using a skill. I will show you how the skill looks like shortly. For technical interview, it's like it asks me question like I'm the interview engineer role, and then respond to it. I will not finish all the questions. It will take probably 30 minutes, right? So I will just run a little bit, and then you get a sense how it works.
So we're showing the art of the possible here, right? So on how these voice agents work.
Yeah, let's do it.
Hello, I am an AI interviewer for a software engineering role. We will go through 5 questions with brief follow-ups after each. Ready to begin? Great. Let's start with the first question. Tell me about a time you debugged a complex production issue. What was your approach?
Okay, I will go very brief, right? So I do isolation, try to understand what is problem from the business aspect, understand under the hood how many systems, how many components, right? And then try to isolate which part causing the problem, and then dive deeper into the code, etc., etc. And then I will give you some samples.
Great example. Thanks for sharing.
So can you move on to the next question?
Sure. Moving on to the next question.
All right, that was a quick one, right? So first of all, I hope you feel how the interaction feels like, the voice quality from Noah Sonic. So this demo is using Noah Sonic as the model, and we use the framework, which is the Strands bidirectional streaming agent, BIDI agent, which is a framework designed for bidirectional streaming models, supporting not only Noah Sonic, but also OpenAI and Gemini streaming models. I also try to quickly show you the barge in, right? So before I hear the response, I said like, move on to the next question, right, etc. And also I did a demo the text input, right? So instead of say yes, I typed yes. This is multi-model input, right? So you can both talking and text to the model, managing the whole contact in one conversation history, so it knows what to respond. Which is very useful if you're building a social, like a web application or a mobile application, allowing user to talk and also to type. Can be also used for the telephony integration because, so for example, the DTMF, if you have numbers using typing keyboard, those numbers can convert to text, sent to the model directly. Yeah.
So you were able to integrate the DTMF also into the application and then send it to the model, so the
Right.
model will understand the tones.
Yeah. So that's usually upstream, right? So for telephone integration, we usually say the voice conversion layer is happened upstream between the telephone and your voice agent. So this layer is streaming the voice back and forth, and then the telephony platform supported DTMF. They're able to convert it to text, and then you can directly sending this text message to the voice agent model.
Yep, and this is how the bargain capabilities, like Lana showed, are more natural to any conversation that we're having all the time, right? So maybe you're calling a customer service agent and asking questions, and then maybe you're interrupting multiple times. But we want to make sure that the agentic frameworks are also able to do the same thing. So that's the barging capability that Lana showed just now with the voice agents.
Right. Yeah. So barging is mostly managed by the model because under the hood, the application, when I barge in, like I interrupted, under the hood, the model will return a signal to your application saying there's a barge in happened. So you can manage the client experience. And then in the meantime, on the server side, they will pivot to the new topic because there's a barge in happened. And then the demo, I was using the Strands bidirectional agent. It's from the Strands family, support a WebSocket interface. right? So this is illustrating the high-level conceptual diagram. It greatly simplifies the programming interface. So building a voice agent using strands by the agent is like 10 lines of code. So you get a voice agent up and running as a WebSocket, and then you can implement the tools using the same manner if you're familiar with the strands text agent programming interface. And also it encapsulate, it's a layer of encapsulation. So it supports multiple providers, the streaming models, although these models may have different event interface. Using strands, they aligned all the models to the same event interface. So your application layer doesn't need to change if you swap the model under the hood.
And that happens all the time, right? When people are experimenting with newer models or newer versions of the models that are available, you want to be able to maybe change a little bit of configuration and let the rest of the code remain the same.
Absolutely. Especially for POC prototyping, right? So you want to have a quick experiment for different models. In using strands by the agent, you just provide a different key, and then you're able to try it out without building something from scratch. However, for production, there's more consideration. You need to test it thoroughly, right? So I rarely see customers just swap in production like a quick decision. It's more a process rather than the coding interface.
Excellent.
Yeah, so on the screen, this is a simplified sample about the strands by the agent, how you build a voice agent using strands by the agent. Fairly straightforward, right? So if you're familiar with strands or the other agentic framework, it's basically, I create a model. In this case, I create a Noah Sonic model with model ID and also the other configurations from Bedrock. And then I create an agent by passing the model, passing the tool, passing the system prompt, and then it's up and running as a WebSocket server, right? So the voice agent code can be as simple as this.
Mm-hmm.
If you previously if you're working with the raw interface SDK for Noah Sonic, it can be quite lengthy because it has a lot of logic to manage the network layer logic. With strands, is all encapsulated, so you don't have to worry.
And strands is an open source framework that's available for anyone to use, right? So you can use any model of your choice. And here, is this considered as a plugin, Lana, in strands? The BID agent, is it available as a class that you can import?
Yeah. Strands is a open source framework, right? So BID agent is one of the module within Strands. Strands has a Strands agent. We usually refer it as for the text interface. You have LLM. It offers a RESTful interface or one-way streaming interface suitable for text chatbot. And then Strands BID agent is specifically designed for bidirectional streaming, mostly voice agent, right? So there's slightly different implementation, but programming style interface-wise consistent, right? So that's a benefit. It's open sourced, open for community to contribute.
And is this all the snippet that takes to create a voice agent, like in these few lines of code?
Yeah, so hello world, that's what right? So the real world, devil's in the detail, right? So real world application is much more than this usually. All right, and then so the demo I show you is fairly simple, right? And then seriously, I just took me 5 minutes to build it from scratch, right? So this is something we really excited. I want to show you the revolution of coding, right? So AI coding tool. I'm using Kiro. Like you can do the similar stuff using, for example, Cursor, Claude Code, Codex, right? So similar concept. What I did was it's also published. We will share the link for the skills. So in this case, we have a skill published for Noah Sonic voice agent. So what it does is include the instructions helping the AI tool to build a voice agent from scratch. Basically, it's a simple one because for my voice agent, I have two components. One is the server side, which is a voice agent, offers a WebSocket server over the internet, right? So that's traditionally the server side of the code. And then another side is client. Client is, in my case, is a website. It's a static website using JavaScript. And then the client side include the logic, for example, the WebSocket client logic, listening to the events, the audio transcoding, like encoding my microphone voice and decoding the voice received from the internet and the additional concept, right? So the skill is breaking down by client reference as well as server reference. So basically, it's just teaching the model how to build all the tricks you should be aware when you build a voice agent for the stack, right? So the stack of this choice is strength by the agent plus Sonic. There's the other stack, right? So for example, LiveKit plus some cascading models, etc.
So are you saying that all that a developer or a builder needs to do is use the skill and let the AI coding assistants take care of the actual build of the voice agent itself?
Yeah, absolutely. Let me zoom in a little bit. So this is a sample we have in one of our workshop. It is a sample instruction. I passed to the tool. This is a prompt. Basically, I'm just saying, hey, use this skill. I want to build a technical interview voice model, and you can just as simple as that. It will make up things, and then you can modify iteration after that. But I give it more instruction, more precise instruction, like what 5 questions to answer, what type of tool you should define, right? So you don't have to go this complex. You can just give it a simple instruction, and then just paste it in the chat. So it started generating. It takes a few minutes, and then you see a scaffolding and then create the application. So in my case, it's already done. So it created a 2-folder client and a WebSocket with code, and also it give me an instruction readme, instruct me how I launch those 2 applications so I can test it on my local machine, right? So that's the application I just demoed, which is this one, right? And then there's debuggings, right? So for example, oops, why this one shows object? It should show text format, right? So I just go back to the agent. I usually do this. This is a different topic, right? So how you debug and iterate using programming tool. I just passing the chat history, and then I blaming my tool saying, hey, this is wrong, without pointing what's wrong, right? So it reads the chat history and it knows what's wrong, and then it will give me instruction and then it will fix it. And then I just test it again. Yeah, life never been easier as a builder with the AI tool.
And point the log files to the AI coding assistant and let that assistant figure it out, right? So what Lara showed us in the last few minutes is to quickly build like a voice agent and test it in your local machine, right? So being able to give some instructions. In this case, it's an interview assistant, interview agent. If you were to build a customer service agent, to modify the prompt and then wait for a few minutes, give the instructions to the assistant, and it scaffold the project for you. Now, how do we take this, Lana, into an environment where we can host it and make it scalable and available for users?
Yeah, thank you for asking. So just a little highlight about the different frameworks, right? So
let's go there.
This is recently we try to use a term like a stack. Remember back to 10, 15 years ago, for full stack developers, you know your stack, like your LAMP, your min, right? So I feel that applied to voice agent as well, right? So the framework of your choice, the model of your choice, where you host it, right? And then how you integrate with agentic framework. So those are really aligned with the traditional full stack. LiveKit and PipeCat are popular frameworks of choice, right? So they both open source version can be deployed on AWS. They also have their own commercial cloud. You can use their hosted service for their voice agent server. So I will not elaborate too much on that. And then so the topic Anil just bring up was agentic integration and hosting, where you host it and how you integrate it, right? So AgentCore, I know, is a hot topic for this series of session since it announced the last year. So for AgentCore, when you talk about a voice agent, is usually served two roles. One is hosting, right? So you have your application, which is your voice agent, is an application where you host it. Traditionally, you can host it on container, and you manage the network security layer. You can also host it on AgentCore runtime. AgentCore runtime offers is referring as bidirectional runtime. It's suitable for voice and video streaming type of application. It's like a managed container service, so easy to deploy and also manage the security aspect of the work. A second one is agentic integration, right? So for POC, for quick testing, you can just write an in-application tool, like mark it as a tool, as a function. It works to quickly test it out, but in production at scale, there's different requirements, right? So this way you can integrate with the other AgentCore features, for example, gateway to serve MCP server for your voice agent to access. You could host the sub agent on runtime as text agent and connect it to your voice agent through the 808 protocol. You can integrate with memory, AgentCore memory for state management, and also AgentCore built-in telemetry can help you to get more metrics in runtime for your production environment.
So what you're saying is that we built the POC and it looks good, using the skill, and then use that, runtime, AgentCore runtime to host the application, the voice application, right? So the back end of it.
Yeah, absolutely. So you host it on AgentCore runtime, right? So that's hosting. And then the others like memory, gateways, telemetries, or agentic integration, additional features help you to build a solution more efficiently at scale.
Sounds good.
And then we have a little bit of deeper dive into different architecture patterns. There's also a blog we will reference in the chat. It's like different patterns is aligned with text agent architecture, right? So when you start with Hello World, probably you just have one or two tools, it works perfectly. And then we see the solution grows, right? So the numbers of tools keep on growing. When it's minimal, you could, MCP is a good, reasonable protocol to integrate with these tools, right? So for example, the sample we say it's a banking agent, I call in, they ask, what's your name? And then they ask me to authenticate. What's your account ID? What's your date of birth? Make sure you are qualified to talk. And then you could start to ask questions. What is my account balance? What is my mortgage refinance option limit, etc. Right? So under the hood, each question is addressed by different tools, integrated with different systems, mostly internal, external. Right. So this the most straightforward way to integrate this type of tool is using MCP tool. They are sort of static. There's no brain, like no reasoning on the MCP side where you can host it on the AgentCore. So it could be on AgentCore gateway, or you can be any place you host your MCP server, right? So that's the basic pattern, but it grows, right? So as your agentic orchestrator logic getting more complex, you have more and more tools to manage, and it comes with more validation logic, saying, for example, validation logics and then special business logics. It grow into a monolithic application really soon. So another popular pattern we see customer adopting is sub-agent. It's basically you have your specialized agent for different subject, right? So in this case, we show there is a specialized agent for authentication. There's a specialized agent for banking agent. The benefit of that is your brain, your orchestrator, your voice orchestrator gets simpler, right? It doesn't need to know all the details of everything. It just know whenever it just know the skeleton of the conversation flow, right? So when the user start, I need to authenticate them, make sure, and then how to authenticate, what is required for authentication, decided by your authentication agent. And then when user ask questions related to banking, then I dispatch it to the banking agent. It's like a intent classification type of requirement. So it helps you to simplify your orchestrator agent, and then also it's just like traditional microservice architecture, right? So scalable, testable, and manageable, etc.
So now in this architecture here that's showing, Lana, so we have like a banking agent and an auth agent, right? So different runtimes hosting the agents, voice agents. Now the runtime that's invoking it, can we switch between them, or do we route it and then let the maybe banking agent take over?
You could, right? So I know there's more advanced architecture pattern you can do Swarm, but me myself, I have an engineer background back to the year before joining AWS. I've been relatively more conserved, but it is a valid pattern. But this is more orchestrator sub-agent architecture, right? So you're pretty much relying on your voice agent as an orchestrator to deciding on which one it should call and what information it should come back. And then you could have additional hierarchy under the sub-agent, right? So, but it's more, you still have a central brain. Me myself haven't tried Swarm in voice agent for a good reason. So because we talk about the benefit of sub-agent, it makes sense from architecture aspect, right? So, and also a lot of customer come ask for this because, for example, they already build a text agent, they have their agentic farm or gateway in place already. They want to reuse it. But a voice agent have a very special nature, is very sensitive about the latency, right? So if you have a text agent, you ask a question, so it's okay. It takes, for example, 10 seconds to sync, and then it dumping a long paragraph with links and paragraphs for you to read through. That's acceptable behavior for text agent. But for voice, it will be you're waiting for quite a period of time. You feel the line is dead, and then it starts responding 5 minutes nonstop. Then
Right.
that's not a good experience for voice.
Yeah, and maybe like another question is, we have this in the chat. James is asking us in the chat, can it work with wake words like maybe Hey Siri kind of thing, right? So
Yeah,
how,
yeah. So that's a weak words is usually a little more involving the client side implementation. For wake word is usually IoT device, right? So you want to wake it up, like I have my Alexa in the room. I don't want to wake it up. No. So it's the common practice we see is you can have a smaller model trained specifically just for this wake word, so they can deploy it on the edge on your device, and then when it's wake up, it start open a connection because voice agent bidirectional streaming is a persistent connection for the latency requirement. It's streaming, right? So there's events going backwards asynchronously. So once it's wake up, it build this connection to your voice agent on the server and then start to talk, right? So there will be a little implementation on your client device side, but a light manage to manage the session lifecycle.
got it. And another question is, again, when we implement the agentic framework here, right? So you spoke about in the previous slide, memory, right? So maybe we can talk about memory on how we can hydrate the conversation, when somebody's coming back with the conversational history.
Yeah, memory is more powerful, short-term memory, long-term memory, right? So from voice agent aspect, um, we consider as state management, right? So you have your application, it could be voice, it could be anything, right? So it need a state management. The most common requirement for voice agent state management is chat history, right? So because voice agent, once you have a session started, the model itself will maintain the state. It will keep the chat history, so you don't have to, like a text agent, you keep on sending the chat history on every single call, right? So the model, the session itself keep the state, but once the session stopped, you lose all the contact, mostly for compliance reason, right? So they are not authorized to really keep your conversation in state. So conversation history, chat history usually can be restored by your application, like your framework, which manage the model. So you can keep it in the AgentCore memory, short-term memory as a chat history. And then when there's a new session start, Nova Sonic, for example, most of the model have this interface. You can send in the chat history when the session start. And then the new session, it feels like from the user aspect, because they are one connection to the application, they don't feel there's a drop in the middle of the session. They just feel they are continuously having the same conversation with the agent. So that's a very practical use case for memory usage. The others is like, for example, caching, right? So because voice is extremely sensitive about the latency, for customer, we see them adopt the sub-agent architecture. So they have a sub-agent, they implement a cache in the sub-agent level. So for example, if the customer user asking question about my today's transaction versus yesterday's transaction, they don't have to hit the database twice. They kind of store some session on the sub-agent level to address the questions. That's referred as passive caching, right? Also, we see customer do proactive caching. It's like when the user authenticate, they try to pull everything, which has a high chance the customer will ask. So this way they can serve faster, right? So for this level of caching, they can utilizing the AgentCore memory.
And also, like I see the summary there, right? So it's one of the aspects of memory, AgentCore memory. So how does that work with the live conversations, right? So maybe if you can talk about that. So when we're having a conversation with the agent, will it get summarized after the end of the session?
Yeah, it's a common, right? So especially for contact center, post-call analytics is a very popular feature. You want to analyze the conversations for quality and the other compliance reason. For the model itself is in real time because it's text in, text out. Text out is giving you the transcription in real time, right? So what the user said, what the model responded. So and then your this application keep this the chat history in a state, which could be, for example, AgentCore memory, and then you could apply additional LLM to summarize it, right? So which can be a post process, depends on your latency requirement.
All right. So right now it looks like we are able to build a voice agent in a few lines of, essentially asking the model to prompt with the prompt using the skill. So then we looked at how we can deploy that. And now Lana was speaking about a few of those patterns. Lana, do you have any more patterns that you wanted to share? Or
Like,
we could go into the next topic, right? Which is, again, we have this question coming in the chat about Kubernetes in context, and maybe we can talk about hosting, right?
yeah,
Hosting options.
yeah. So if you look at the AgentCore deployment, it's actually containers as well, right? So the source code, including a Docker file, which copy the source code and also have additional logic when your service is up and running, how it refresh the authentication token. It may help you to truncate the audio segments into smaller pieces in case you have some network constraint, those type of logic. So the deployment package for AgentCore is the same, almost the same as any container service like Kubernetes, right? So we do have some CDK package, Terraform package, showcase how you deploy voice model, for example, Nova Sonic model to AgentCore, right? So that's a hosting option. For the few slides we just went through, we're talk about AgentCore deployment. Yeah, we see we dropped the link. Yeah, so
Yeah.
I will share some samples, right? So if you're interested in EKS, on AWS, it will be ECS, EKS, which is container-based management services where you can deploy your voice agent flexibly. And then observability, right? So AgentCore, the benefit of utilizing AgentCore, you get a default metrics offered by AgentCore, help you to monitor your service, and also you can implement customized metrics, right? So for example, some voice is sensitive about time to the first word. Those type of metrics usually not monitored by the framework by default, and then you could just write an event yourself using the X-ray library, and then use a custom dashboard to present those type of insight. Container. So what I try to say, like deployment, for example, EKS, Kubernetes, or AgentCore, they are really framework agnostic, right? So it doesn't matter which framework you use, which model you use. You just deploy them as a container application, right? So through WebSocket port or through WebRTC port. So it's really a layer you can decouple from your framework and model. That's why we're breaking down the topic into 4 logical areas.
Now, how do we differentiate between WebSockets and WebRTC? I know you mentioned that, so maybe you're going there next.
Yeah. Thanks for asking. Right timing, right? So WebRTC is a very popular topic. Whenever we talk about a voice agent, you couldn't avoid this topic, right? So because WebSocket, WebRTC is the open source framework, we see a lot of customer want to adopt open source framework like LiveKit, PipeCat is mainly because the WebRTC native WebRTC support and the other like SIP support, agentic integration, etc. And then simply put, WebRTC is more UDP based, right? So we know it is like good for latency and suitable for poor network condition, right? So if you don't have a good quality of internet connection, WebSocket is more generic because it's just a bidirectional streaming interface. It could be serving anything, not only video and audio. WebRTC is more, when you're referring WebRTC, is more referring to voice and a video conference type of application. Speed versus reliability, right? So WebRTC usually referred as faster because it's UDP based. WebSocket can be slightly slower because it's more TCP based, like there's handshake involved. And then connection type, but one thing we point out is WebRTC offers a feature for peer-to-peer connection. It's like if you have a Zoom call, you have a team call, right? So there's multiple people or agents connecting to the same session. And then the peer-to-peer connection is really handy for this type of use case because in between 2 devices, they can directly connect, right? So versus WebSocket is usually a server client type of architecture. But for the voice agent architecture, we see more often is like server client, right? So in this case, it's less relevant, I would say. Depends on your use case. But if you have a video conference, the peer-to-peer connection is a pro. And also WebRTC, a lot of client-side device have a very native support for WebRTC. So for example, if you build a browser-based client application, so in our case, you can see, although AI make it much easier, but a WebSocket client still pretty involving. There's a lot of complexity about audio and the WebSocket client management. With WebRTC, it can be much simpler because the browser SDK has a built-in support for a lot of functionality.
So now how does this all come together with our voice agent, right? So with WebRTC and WebSockets that we're discussing.
Yeah, this can be opinionated, open for debating. But the high-level recommendation is more if you need a peer-to-peer conversation, ultra low latency, or your device will functioning in the area where the network is not super reliable, WebRTC can be a good choice. WebSocket is more, you have a client to server pattern. You are doing rapid prototyping because WebSocket is easier to build actually because it's more standardized, easy to start. Later we will highlight WebRTC has an additional service required like turn server to serve the whole solution. It's not just a protocol; it's additional component required for your network. And it's transparency, right? So learning in terms of learning curve, WebSocket is usually easier to pick up. There's no, and also for telephony, we see customer usually using WebSocket because it's more reliable. It's a server-to-server conversation, right? So your telephony server and your voice server are both hosted, and then they sometimes also, even in the same network, the WebSocket is sufficient in this type of situation. Yeah, open topic, open for debating.
And is it supported with our voice, with our frameworks that we are talking today?
Yeah, so we have some solutions published for WebRTC for support because AWS is offer building blocks, right? So you can mix and match different components together to serve your solution. And then for container service, if you're doing EKS, ECS, WebRTCs, you can just deploy your own turn server, deploy your own voice agent, and then open the UDP port, manage your network security, right? So traditional networking setup. And then for AgentCore, also AgentCore runtime by default is support WebSocket, and it will also work with WebRTC. And then this is the level, because for WebRTC server, you usually requires a turn server, right? So in this case, we are collaborating with Kinesis Video Stream offers the turn server to complete the whole life cycle of WebRTC. And there's also sample code available on the AgentCore sample repo for WebRTC deployment on AgentCore. We also have published the deployment package for PepCat, the live kit on container service like EKS, ECS with WebRTC network setup involved.
Yeah, so there is a link to the description of this video where you'll find the the links to the GitHub repository and other samples that we're sharing today. So take a look at that description.
Yeah, I see one of the questions latest in the stack is can we use S3 file system here? I'm not sure what is this referring to for S3. Maybe for the state management, right?
Right, I guess so. Maybe using tools, right? So create a tool that can access the file system, and then being able to mount the S3 as a file system, and then use it that way, right? So that's maybe one of the solutions.
Yeah, probably when we discuss this memory state management, I feel it's case by case, right? So voice agent is in nature you consider it as traditional software development, right? So how you integrate with your tool is usually based on your requirement. If you have a relatively low latency, higher latency requirement, it doesn't to be lightning fast, then you could save your data to S3 file system. For example, I want to keep my chat history, but I don't need to take any action in real time, right? So I don't need to pull it out. I just store it for my post, like batch process running over the night to analyze the call quality. In that case, I just have an asynchronous process to store it into the S3 file system, right? So it's cheaper and also scalable, support high concurrency.
So Lana, let's now talk about the telephony aspect of it, right? Because that's something that you mentioned earlier.
Yeah, sure. So we have a few slides cover telephony. Telephony is a very important topic for voice agent. For voice agent, we see two camps. One is the traditional contact center. So they have human agent answering call 24/7, a large fleet, right? So for this type of platforms, traditional platforms, you may see the names and all the customers on the screen. So those are our telephony customers with Novasonic. So using voice agent will significantly helping them to improve the quality and also scale, right? So it's just matters of how many voice agents you connect into the line, and then there's no training required for those voice agents. So that's a larger stream. Another one is the agentic community, like customers building text agent, and then you want to add a voice agent framework. You want to add a voice interface to spice it up. For telephony, it's more like the client. You can think about it as a client side. From the voice agent aspect, the client side is different, right? So if you build a web application, mobile application, your client device is collecting the voice, do the transcoding and send it to your voice agent application. In telephony, it is from the caller, which is from the phone call, and then through the public telephony network, and then to the VoIP provider, right? And then this telephony platform is integrated with your voice agent application. So basically, simply put, it does the audio transcoding, right? So the input, there's different format from the ULAW to PCM, and then when this audio streaming going back to the telephony platform, you convert it back to the PCM to the ULAW format. And also there's sample rate conversion. So that's an audio conversion layer of this type of transcoding. So for the traditional platform like Genesis or Amazon Connect, 5 nines, they are usually involving the SIP trunking server as a protocol. And also there's some more modernized solution like OneEdge, Twilio. So they offers the streaming API, which is relatively more easier to integrate. For Twilio and OneEdge, we have open source the sample, show you how you integrate those telephony solutions with voice agent on AWS, right? So you just get their key, so you can have a phone number call in, and then on the other side, it's your voice agent hosted on AWS. Yeah, so here's an example how to integrate with OneEdge, contributed by our heroes of voice agent. All right, so that's pretty much what we covered from the talk track aspect of voice agent, right? So we covered the frameworks and the models, cascading versus bidirectional streaming, and different models suitable for different framework. We talk about agentic integration utilizing the AgentCore features. We talk about how you host it on AWS, mostly focus on AgentCore, but container service are very similar pattern. It's just self-managed. We also briefly touch upon the telephony integration for your voice agent.
And most importantly, we also spoke about the skill as well, right? So to get you started pretty quickly, and let me see, is the skill also present in the samples repository, Lana?
Yeah, so it is in the one of the sample we have a skill. It's like the NOAA sample, the Amazon NOAA sample repo. On the root level, there's a skill folder. It comes with the skills. So one of them is text to voice migration skill. So basically, you can just to say I have a text agent. It could be for example, on the source code is on the GitHub. You just share the URL in the AI tool, and then use this skill to convert this text agent, and then in few minutes it launch a voice agent for you.
Yeah, there is a number of blogs as well in that will link you directly to the source code, and they're attached to the description. So feel free to check it out. Yeah, so we've covered how to build and host your voice agents on AWS today. Next week we'll have another topic, which is how to monetize, right? So how to get your agents to buy the content, right? So using protocols and the X402 protocol specifically. So come back, tune in next week, same time on the AWS Show and Tell, right? So signing off from this side today. Thanks for running this, Lana.
Thank you for having me.
Bye.
Thanks, everyone.